We start now with the introduction to refrigeration system. What is industrial refrigeration? So, this is Untitled Chapter. Una natin ko na industrial. One characteristic of industrial refrigeration is the temperature range it embraces. While evaporating temperatures may be as high as 15 C or 60 Fahrenheit, the range extends down to about 60 or negative 70 C, negative 76 or negative 94 Fahrenheit. This is negative 60 C. So at temperatures much lower than that, negative 70 C, another industry called cryogenic takes over, producing and using liquefied natural gas, liquid nitrogen, liquid oxygen, and other low temperature substances. Figure 1 shows the machine room of a refrigerated warehouse, which is one of the main examples of industrial refrigeration and the food industry. Another significant application exists in the manufacturing industry and in laboratories where special conditions, especially low temperatures, must be maintained. Next is the refrigerated storage of unfrozen foods. The shelf life of foods, of most foods, is enhanced by storage at low temperature. So figure 1.2 shows the shelf life of several food products as a function of temperature. Example, if you storage temperature, storage time in months and days. If the storage temperature in degree C, sa taas is in degree Fahrenheit. So itong mga numbering na yan, kaya so number 1, chicken, 2, lentis, 3, beef, 4, bananas, 5, oranges, 6 apples, 7 eggs, and 8 apples stored in controlled carbon dioxide and steam. For example, at 10C, number 1 is the chicken, so the shelf life is 4 days. Okay. Pag binabaan pa temperature, tumataas. Mahaba. So the life of all products shown increases as the storage temperature drops. But for certain food products such as bananas and certain kind of apples, the optimum storage temperature is higher than the freezing temperature. For the product shown in figure 1.2 and for most meats, fish, foods, and vegetables, the storage life can be prolonged by maintaining the product at low temperature. Later sa topic ng cold storage, discuss natin ito. Many foods are stored in the unfrozen state, like rarely unfrozen. For example, bananas, apples, tomatoes, lettuce, cabbage, potatoes, and onion, fresh siya. So, ito frozen mo. The optimum storage temperature of several products from the perspective of both preservation and economy are shown in table 1.1. Ito yung mga design temperature storage. Hindi ka basta mag-assume 0, pero 0. Ayan. Pero kasi above 0. Some foods can be stored at temperatures slightly below 0, 32 Fahrenheit, without freezing because the water in the pot is in a solution with sugar and other substance, providing a lower freezing point than 0 C. Some refrigeration plants are loaded on stock trailers as in figure 1.3 and moved to grow areas during harvest season. Pagka-harvest talaga dyan, refrigerate niya na si pagkain pa siya. Check the lecture. Medyo mahaba, no? Next, doon naman tayo sa frozen foods. The history of frozen food goes back to the middle 1800s. As early as 1861, fish was frozen with ice and salt and stored for 8 to 10 months. The first successful ocean shipment of frozen meat was on the French ship Paraguay in 1878, when it sailed from Buenos Aires to France. In 1880, the SS Scotland transported a load of frozen meat from Australia to England. In North America, during a scientific expedition to Labrador in the years 1912 to 1950, expedition member Clarence Burnside noticed that fish processed at sub-zero temperatures maintain their quality for long periods. Now, popular methods of freezing foods include air blast freezing, where low temperature air passes at high velocity over food packages. Blast. Contact freezing, packed or unpacked food is placed between refrigerated plates. Immersed freezing, food is immersed in low temperature mine. Belt pressure, which pulls low temperature air at high velocity from underneath the belt. Spiral freezers, where the product is conveyed on a conveyor belt within a low temperature chamber. And a cryogenic freezing using liquid carbon dioxide or nitrogen. Ito yung mga method of freezing. Now, in the distribution chain, frozen foods must be stored, mga mall, mga grocery, perhaps first in large refrigerated warehouses, then later in small quantities near the grocery market. Storage temperatures for frozen foods are typically between -20°C or -5 Fahrenheit and -23°C or -10 Fahrenheit. Let's check na lang ha. Although some products such as fish and ice cream are usually stored at lower temperatures, warehouses storing fish often maintain temperatures as low as -30°C or -22 Fahrenheit. Food like ice cream behaves similarly to brine or anti-freeze. The water begins to freeze at a certain temperature, which concentrates the remainder and lowers its freezing temperature. The range of temperatures through which ice cream passes as it freezes starts at about -2°C or 28 Fahrenheit and ultimately reaches -30°C, -22 Fahrenheit. Ice cream is packaged at about -5°C or 23 Fahrenheit, at which temperature it is steep but will still flow. Then it moves to a hardening room kept at 30°C or -22 Fahrenheit for complete freezing. Ito yung process ng ice cream. Now, refrigeration in food processing. The usual purpose for refrigerating and freezing food is to preserve their quality, which technically is changing what would be natural processes of deterioration, panis. Refrigeration may also play a role in facilitating a change in the character or chemical structure of food called processing here. Next, freeze drying. Yung figure. Freeze drying is a process that finds application in both the food industry as well as some process industries such as pharmaceuticals. The processes include first freezing the product, then removing the water by sublimation, in which the water in the solid state converts directly to vapor without passing through the liquid state. To carry out the sublimation process, it is carefully added to the product being maintained under a vacuum in the chambers as the one shown in figure 1.5. To achieve the vacuum, a combination of refrigeration and mechanical pumping is employed. The mechanical pump mostly removes the air and other non-condensable gases, while the refrigeration system chills an evaporator to around -50°C or -58 Fahrenheit. Water from the product deposit on the evaporator coils in the form of frost. Refrigeration thus serves the initial freezing process as well as the evaporator coils of the vacuum chamber. So, ulit, Ulit. Number 9, refrigeration in manufacturing plants. There are frequent and varied needs for refrigeration in the machining, forming, and fabrication of products made from metals, plastics, and other materials. An example is the cooling of the fluid sprayed on the point of contact between a machine tool and metal. In many factories, a network of pipe carries compressed air for air motor and other uses of air for power throughout the plant. When air, particularly humid air, is compressed and brought back to room temperature, water in the compressed air may condense and adversely affect the operation of equipment using the compressed air. To condense the water where it can be removed, some compressed air systems use a refrigerated heat exchanger located immediately after the compressor. So the compressed air is ideal. Many manufacturing plants operate environmental test chamber to duplicate or even exaggerate extreme conditions to which the product might be subjected during normal use. These extreme almost always include high and low temperatures and high and low humidities. Environmental test chambers call for refrigeration to achieve their low temperature. The task of the refrigeration plant is usually to provide a source of low temperature air. Now, refrigeration in construction. Meron din tayo niyan. Two important uses of refrigeration in large construction projects are the cooling of large masses of concrete and the freezing of soil to facilitate excavation. During the hardening of concrete, its chemical reaction is exothermic, and if it were not removed, the high temperature would stress the concrete. Concrete may be cooled by chilling the sand, gravel, water, and cement before mixing, or by embedding chilled water pipes in the concrete. Another application of refrigeration is the freezing of wet soil in the vicinity of excavation to prevent caves in. The typical pipes are driven into the soil surrounding the area where excavation is to occur. Then cold brine circulates through the pipe coils and freezes the soil in its vicinity. When the frozen zones overlap, excavation can be proceeded. Ice rinks and facilities for other winter sports. Some ice rinks serve specific purposes, such as recreational or speed skating, hockey, and curling, while others are the general purposes that at different times are used for different types of event. Desired ice temperature are typical to -5°C, 23 Fahrenheit for hockey, -3.5°C or 26 Fahrenheit for figure skating, and -2°C or 28 Fahrenheit for recreational skating. The ice is maintained at a thickness of approximately 25 mm, 1 inch, by passing either cold brine or direct refrigerant, R22 or ammonia, through a grid of pipes in the ice. The brine or refrigerant temperature is usually held about 5°C or 9 Fahrenheit below the desired ice temperature. Now, refrigeration in the chemical industry. The pharmaceutical industry has already been mentioned as a user of refrigeration in the freeze-drying processes. And of course, that seems popular in the industry is also to chill a fluid and distribute this cold fluid, what is glycol, antifreeze, or alcohol, for example, to the location where refrigeration is needed. Low temperature alcohol may chill the jacket of a vessel, or glycol may be sent to air cooling coils located in a room where peeling of powder is taking place that must be maintained up to humidity. The chemical, petrochemical, and oil refining industry often need large-sized refrigeration plants. Some important operations often requiring refrigeration are separation of one gas from another by liquefying more of one gas, condensation of gases such as capturing gas venting from a liquid storage tank, solidification of one substance in a mixture to separate it from others, or hygroscopic material. Maintenance of a stored liquid at low temperatures to control pressure in the containing vessel. Removal of reaction heat. Humidity control for hygroscopic material. So, dito to. Dito. So, wala to. A list of just a few of the industries and the temperature range of their application needs a pre-cooling air prior to separation. 100C or negative 100C or negative 148 Fahrenheit, condensation of hydrocarbon vapor taking place at negative Fahrenheit 55C or negative 67 Fahrenheit, and in the manufacture of such chemicals as ammonia, urea, aniline dyes, butadiene, butyl rubber, chlorine, pesticides, herbicides, synthetic rubber, vinyl chlorides, and silenes, as well as in the recovery of solvents. So this is the end of this topic.